All right, today we're going to talk a little bit about variable charge metals and how to tell what the charge is on a variable charge metal. So let's remind ourselves of our variable charge metals. We have the three musketeers. We have the lowest L. And we have tin and lead. Remember, the three musketeers can have a +2 charge on the ion or a +3 charge on the ion. We singled out 3 of them so you could remember which ones were +2, like all of the transition elements, and +3. Copper is part of the lowest L, meaning that it can have a +1 charge or a +2 charge like the rest of the transition elements. Gold is part of the lowest L, and it is 3 down, so that's going to remind us that we can have +1 or +3. Mercury can be +1 or +2. I wrote it like this because +1 always comes in pairs. Now, tin and lead are in family 4, so they can be a +2 like all the rest of the metals, and a +4. So now let's go over the types of compounds that it can form. Each of these metals has 2 possible charges for us. So each of these metals can form 2 possible ions or 2 possible formulas for chemical compounds. So let's go over what they would be. If iron is with a -1 ion, you can see that it would form 2 compounds that would have either 2 or 3 of the negative ions. This one we name by saying iron 2 chloride. We change the ending to IDE when there's only 2 elements involved in a compound. And here is iron 3 chloride. The same goes for all of the 3 musketeers. Now, what if they are bonding with a -2 ion? Well, they can also form 2 compounds. So if I have a +2, let's use a different one of our 3 musketeers. If I have +2, they simply go together 1 to 1. So this is chromium 2 oxide. And this would be chromium 3 oxide. Remember, we're going to drop the charges down. Another way you can think of it is when you bump across one of these 8 variable charge metals, you could say to yourself, ooh, that's a variable charge. I've got to pay attention and I've got to figure out what the charge is on it. So we're going to call that X. So we're going to come up with a algebra formula. So I have 2 chromiums. Let's do this one right here. I have 2 chromiums that I don't know what the charge is. I have 3 oxygens that I do know are -2 all the times by looking at my periodic table of ions. And it's a compound, so it is electrically neutral, so it adds up to 0. So if it helps you more, if you're still struggling with how to figure it out, you can do algebra. let's do an example of 4. That's the only one we haven't done. So lead, if I were to go with a anion that is a -2, lead +2 would go 1 to 1. So this would be lead 2 sulfide. If it's with lead +4, if I have 4 pluses in the front, I'd have to have 4 minuses in the back. That's going to make it so I need 2 -2 sulfides, and this would be lead 4 sulfide. So this is how we do variable charge metals. Let's continue on and let's talk about polyatomic ions. Polyatomic ions are going to be on a list for you. I'll put in the assignment for today a list of polyatomic ions. Poly means many atoms working together as an ion. So a lot of times these are covalently bonded, meaning that they share electrons and they stay together as an ion. I'm going to talk to you about some of the more common ones, which are nitrate, chlorate, sulfate, phosphate, and carbonate. Let's form some compounds with these. So nitrate has a charge of -1. That's what that dash means. It actually means a charge of -1. So when you're looking to figure out how many cations to put in front of these anions, remember, cations always written first, you would use that negative charge. So for example, a compound that is going to go with a +1 charge would go with 1 -1, or 2 -2s, or 3 -3s, like such. If you had a compound cation that had a charge of +2, it would go together with 2 polyatomic ions. When I have more than one polyatomic ion, I have to use parentheses to show that I need more than one polyatomic ion, like such. I only need that if I need more than one polyatomic ion. So a +2 cation would go 1 to 1 with a -2 anion. Now, calcium with +2, I know that I have calcium at +2. Let's write it here so we can keep track of it. And phosphate at -3, I can drop the charges down like such, or I can look for the lowest common denominator, which is 6. So I have to have 6 pluses and 6 minuses because that's the lowest common denominator, or I can drop the charges down. That means that I have 3 calciums and 2 phosphates. What about a charge of +3 on an ion? That would take 3 +1 ions. I would drop the charges down for a 2. And it would go 1 to 1 with a 3. So this one's aluminum nitrate, this one's aluminum sulfate, and this one's aluminum phosphate. If I have a +4 ion, it's going to take 4 -1 polyatomic ions, two -2 ions, and if I have the -3 ion, I'm going to swap the charges. So tin would get phosphates -3, and phosphate would get tins +4. So this is tin 2 chlorate. This is, I'm sorry, tin 4 chlorate. This is tin 4 sulfate, and this is tin 4 phosphate.